Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrell's Algebra class. Today we are going to be talking about quadratic transformations, and we're going to be analyzing the quadratic function. So far, we have been learning how to graph functions that are in what's called standard form. Standard form is y equals ax squared plus bx plus c. But sometimes they're going to give it to us in a different format, and it's called the vertex form. And before we learn how to use that, I want to explain how the vertex form came about and what all of the individual pieces of the vertex form are. So first of all, every single quadratic function, every single one, no matter how complicated or how simple, it all comes back to the parent function. The parent function, it's kind of like your parents. You are similar to your parents, but you have differences, correct? Right? Some of you look like some parts of your mom, some parts of your dad. Some of you look like all your moms. Sometimes everyone looks like just like their dad. Sometimes they're tall like their dad, but they have blonde hair like their mom, etc., etc. So you come from parents. You are like your parents, but you're not exactly your parents. This is the same thing with the quadratic function. The parent function is y equals x squared. So I'm going to show you the graph of y equals x squared. This will never change because it's the parent function. If I make a little table and I put -2, -1, 0, 1, and 2, I'm going to get 4, 2, 0, 1, 1, and 4. So 0, 0, 1, 1, -1, 1, 2, 4, -2, 4. That, my friends, is the parent function of a quadratic equation. That is the parent. Okay? Now, what is this vertex form? Well, the vertex form, I promise, is simply a manipulation of the parent function f of x equals x squared. A manipulation means that it was changed somehow. Something was done to it. That's what it means to manipulate. If you manipulate your phone, that means you're doing something different to your phone. Okay? So, when we manipulate this parent function, f of x equals x squared, we get the following vertex form. And this is y equals a times parentheses x minus h close parentheses squared plus k. We are going to investigate what the a means, what the h means, and what the k means. Okay? So, let's start. Excuse me. Okay, first of all, we know from standard form that if the a is positive, which direction is it going to open? Upward. Let's prove it. Y equals x squared. We know that's 0, 0, 1, 1, 1, -1, 2, 4, and -2, 4. Why do I know that? Because we just graphed our parent function. So those are going to be the points forever for the parent function. You with me? And this parent function, it's positive. The a is positive, so it is going to point upwards. What happens when it's negative? It's going to point downwards. And let me prove it to you why. Let's go -2, -1, 0, 1, and 2. Okay, when x is -2, it's going to be 4 times the -1, it's -4. When x is -1, it's -1. When x is 0, y is 0. When x is 1, y is -1. When x is 2, y is -4. 0, 0, 1, -1, -1, -1, 2, -4, -2, -4. And as you can see, the graph points downwards. So, if my A is greater than 0, if it's a positive, you know that it must point upward. If my A is negative, you know that it must point downwards. Everyone with me so far there? Makes sense, right? Okay. Next, still with the A, there's something else that the A tells you. The A is very, 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 very powerful. If the A is greater than 1, the absolute value, it does not matter if it's negative or positive. If it's negative, you know it's pointing down. If it's positive, you know it's pointing up. But if you take the absolute value of that A, the absolute value, if the absolute value of A is greater than or equal to 1, then the graph stretches. And I'm sorry, it's not greater than or equal to, it's just greater than. It will stretch vertically. What does stretch vertically mean? Well, think about it. I'm going to show you this little rubber band. You're not going to have the rubber band on the video, so please watch me. Anyone out there in the internet world, take a rubber band, okay, and go stretch it up. What happens to the rubber band? Does it get wider or does it get thinner? It gets more narrow, right? Okay, that is called a vertical stretch. Let me show you what a vertical stretch looks like. First, let's graph y equals x squared. 0, 0, 1, 1, 1, negative 1, 2, 4, negative 2, 4. That's my parent function. Let me show you what happens when I apply a vertical stretch. Go ahead and make a table. Negative 2, negative 1, 0, 2, 1, and 2. When x is negative 2, we're going to have 8. When x is negative 1, it's 2, 0, 0, 1, 2, 2, 8. So 0, 0, 1, 2, negative 1, 2, 2, 8, negative 2, 8. Do you see that this is narrower?
Yes.
Do you understand that what I mean by vertical stretch now? Does that make sense? Okay, think about it like this as well. When a baby is born, they're all cute and full of fat, right? But as they stretch out and get taller, don't you lose what they call baby fat? Right? Because you stretch out. So this parabola is getting thinner because it's getting stretched up vertically. Yes. Well, that's up for that's subjective, right? Okay, let's get back to parabolas. Shh. Now, what happens if the absolute value of A is greater than, not equal, just greater than 0 or less than 1? If the absolute value of A is greater than 0 or less than 1, that means that it's a fraction or a decimal. Okay? If the absolute value of A is greater than 0 but less than 1, the graph compresses vertically. Vertical compression is the opposite of a vertical stretch. So look at the rubber band, okay? If I compress it, that means I squeeze down on it. Doesn't it get wider? Do you see that, guys? Vertical stretch stretches vertically. A vertical compression gets wider. You with me? Let me prove it to you here. Let's first graph y equals x squared. 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4. That is my parent function. Now, let's graph this guy. I'm going to use multiples of 2, of course. So negative 4, negative 2, 0, 2, and 4. When x is negative 4, we got 16 divided by 2, that's 8. When x is negative 2, that's 4 divided by 2 is 2, 0, 0, 2, 2, 4, 8. So I got 0, 0, 2, 2, 2, 2, negative 2, 2, negative 4, 8, 1, 2, 3, 4, 8, and negative 4, 8, 1, 2, 3, 4, 8. Do you see how that is wider? Okay, so just to make sure everything is clear, if A is greater than 0, you point upwards. If A is less than 0, the graph will point downwards. If the absolute value of A is greater than 0, you're going to get a vertical stretch and the graph becomes more narrow. If the absolute value of A is greater than 0 but less than 1, then the graph compresses vertically and becomes wider. That is everything you have to know for the A term. Does that make sense? Yes, sir. Yes, sir. The higher the A, the narrower it will get. So if I have y equals 50x squared and y equals 12x squared, the 50x squared is a lot more narrow than the 12x squared. Thank you, my brother. Okay, let's continue. Now, I'm going to show you a little trick now, okay? In this case, remember, we already learned what the A does. Now, let's investigate the H. The H is for a horizontal shift. Horizontal. So you either go left or you go right. If the H is positive, it's opposite because of that negative. You're going to go to the left. If it's positive, you're going to go to the left. What does that mean, Mr. Morrow? Well, you're going to love me now in about 2 seconds. First, let's graph the parent function. 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4. Now, if I have this, it's my parent, but how am I shifting it? How many places? 3 places to the left. When it's positive, you go to the left. So guess what, guys? You don't have to make another table. All you got to do is literally move every single point of your parent to the left 3 places. So you go 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And do you see how it's the same exact graph but just shifted 3 units to the left? You do not have to make a new table for that. If you remember this, you do not have to make a new table. Now, please be careful. Notice how this is within the parentheses. If it's outside of the parentheses, you're talking about the K, which is something different. But if it's inside the parentheses, this works. Now, what happens if I have a negative H? If H is negative, like in this example, I'm going to move to the right. It's always opposite. So, how would I graph this guy? First, graph the parent. 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4. But now, I am shifting this graph horizontally 3 units to the right. So every single point gets shifted 3 units to the right. So you go 1, 2, 3 to the right, 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 1, 2, 3 to the right. Do you see how it's the exact same graph except it was shifted 3 units to the right? You got to admit, I made that pretty easy. Okay? Correct, my brother. It's always opposite. And now, last but not least, the k. If the k is positive, okay, well, before I tell you that, the k describes a vertical shift. So a vertical shift is up or down. And it works exactly like the h. If the k is positive, you move up, though. You don't have the opposite thing. But you're going to work it the same way. How would I graph this function? First graph y equals x squared. 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4. Now, I am shifting the graph 2 units up. So I am going to shift every single point 2 units up. So I'm going to go up 1, 2, up 1, 2, bless you, up 1, 2, up 1, 2, up 1, 2. Do you see how it's the exact same graph except it was shifted up 2 units? Do you see that, guys? All right. Very good, my brother. Thank you. If the k is negative, then you shift every point down that many points. So how would you graph y equals x squared minus 2? First, graph your parent. 0, 0, 1, 1, 1, negative 1, 2, 4, negative 2, 4. Okay? Connect the dots. That's my parent. Now, I am shifting my parent 2 spaces down. So down 1, 2, down 1, 2, down 1, 2, down 1, 2, down 1, 2. Do you see how it's the exact same graph except it's shifted down 2 units? Does that make sense, guys? Okay, now, how are we going to put this all together in a very easy fashion? Order the functions from narrowest to widest. Okay? Which one here is more narrow and which one here is wider? What's the a here, guys? What's the a here? What's the absolute value of 5? What's the absolute value of negative 8? Which has the larger a? So which is the narrowest? This is the more narrow, and this is wider. The larger the a, the absolute value of the a, the narrower it gets. Yes, sir. Yeah, I know. It was negative 5 on your paper. Change it to a negative 8, please. Now, how about for B? I want you to label this from narrowest to widest. So of these three, which is the most narrow? Thank you. H of x equals 3x squared because it has the largest a. Who's the next most narrow? F of x equals x squared because the a is a 1. And the last, this is going to be g of x equals negative 4/5. The larger the a, the more narrow. Okay? If the a is a fraction or a decimal, it will become wider. Does that make sense? Promise? Oh, yes, sir. I know we already said that. Change that negative 5 to a negative 8, please. Thank you, sir. Now, let's put it all together. Compare the graph of each function with the graph of x squared. So they want you to tell them, hey, this is what you did to this graph. So let's think about this. First of all, the negative means that it's, okay, so we know that it opens downward. What does the 2 tell you? 2 down. No. What does the 2 tell you? Isn't that the A? So it is a vertical. It is a vertical stretch. And what does the 5 tell you? It's going to be not left. Is that attached to the X in parentheses or outside of the X, guys? So that means it's going to be shifted up 5 units. I'm not making you graph these guys, but you got to explain what shifts we did to this. What about for B? Okay, first of all, what does this 2 tell me as the A? I'm sorry? It's definitely opens upwards. What else does that A tell me? It's a vertical stretch. Very good. Not a compression, but a stretch. What does this negative 2 here tell me? You shifted it 2 units to the right. And what does this positive 1 outside of the parentheses tell me? You shifted it up 1 unit. Yes. The squared has everything to do with it. The squared is what makes it a parabola. The squared has everything to do with it. If there's no squared, you don't have a parabola, guys. Come again? No, why would it be 4 to the right? You mean to tell me that you think that if I square this, this becomes x squared minus 4? Really? Remember that we have to actually do x minus 2 times x minus 2? No, you're not going to do that. Follow directions. What is the value of the h here? So that means I'm going to shift it 2 units to the right, period. Okay? I am allowed to do that because of that 2, because of that power. Okay, how about here? What does the 3/4 tell you? It opens upward. What else does it tell you? No, it is not a vertical stretch. It's a vertical compression. What does the negative 3 tell you? Huh? Shifted 3 units down. Thank you very much. Hope you learned a lot. Homework is valid. Quiz is tomorrow, double quiz. 8-3, 8-4. Have a great day. Bye-bye.